welcome back. So I'm going to have a look at this thing called Code Pilot, which has probably been around for a while, but I haven't noticed it, on ChatGPT, which is supposed to help you while you're writing code, and it's supposed to be a great way to do it. Let's see if it is any good. I've used ChatGPT before to get code, as you remember, in Python. The reason I'm using Python is because it's free and anybody can download it onto a PC, whereas if I use Matlab, it's great, of course, but it means not everybody's got a copy unless they're working at a university. So I'm going to ask it, first of all, what is the fastest way to invert a square matrix? See what it comes up with. So, well, obviously for small matrices it's just using the formula. Gaussian elimination. Okay. Now that's and of course all mathematicians say this: avoid direct inversion. If you're solving ax equals b, they sort of don't like you to invert and say x equals a to the minus 1b, which is what engineers would do a lot of the time. But there are situations where if a was changing with time, that you might have to do something like that. But it's not being very specific. So there's LU decomposition as well, Gaussian elimination. Let's what it's missed out of that is the Newton's method. So I'm going to say show Newton's method for matrix. I'm not sure if it's probably not the fastest, but it's a fast method. One thing you've got to be careful with Newton's method is the initial starting point. Just like when you're working with square roots and things with Newton, or solving polynomials, you've got to be careful where you start your search, or it'll diverge. So this is Newton's method. It says choose an initial guess. Oh, it's actually going to give. I didn't even ask for the code. It's actually given me the code. So choose an initial guess. So it says use the first. So x is going to be our answer. X at some time k. The initial guess is x naught. Is a transpose over. This is the infinity norm of the matrix times the one norm times infinity norm. They're closely related, actually. I forget the difference. It's very, I think it's just summing the rows rather than summing the columns is the difference between the two. It's easy to check on, but there'll be library functions for that, so don't worry about it. So here's the iteration. If A is the matrix itself, x is it's going to be its inverse, so xk plus 1 is xk times 2i minus a xk, and it just goes around that until it converges. And obviously you're going to have to check whether it has converged, otherwise you just go around forever. So here's the code. Now in Python, when you multiply matrices with this, see, it's used the NumPy library. At is the symbol for multiplication of matrices, the at symbol, as in the email at symbol that you use, Tom at whatever. So it's defined this function which is going to give us the inverse, which is going to put a in there. Our tolerance is going to see how accurate it is 10 to the minus 10, and the maximum number of iterations is 1,000. It shouldn't take anything like that for a 3x3 matrix. It's given a 2x2 matrix. I see. I might change that to 3x3 in a minute. But anyway, let's just try the 2x2. And it's got a thing to say if it didn't converge. Let's see where it it finds out where oh, there it is, the tolerance. So it's working out the difference between the actual inverse at the present iteration k1 minus the previous iteration at time k. K1's the new iteration, obviously. The first time I've seen this, just like you, when I'm looking at it, I haven't seen it. So if it's less than the tolerance, that means it's finished and it returns the value. Otherwise it didn't converge. So let's copy it, stick it into this. Now I'm using PyCharm, I think it's called, which is the environment for Python, but you can, yeah, PyCharm, but you can use anything you so choose. And this is the program that it's given me, and let's see if it works. Oh, there's the inverse. I assume that's right, the inverse of 4726. Let's increase this, make it 3 by 3. See if it works. 471. It's a bit like entering matrices in Matlab. So I don't know if this is singular or not. I hope not. I need another row. 5, 7, 9. Let's see. Just pick that off the top of my head. So now that's a 3 by 3, and I don't think there's anything. Yeah, so it works out the order here of the. It determines the order from this a.shape thing. It tells it the order of the matrix. So I don't need to tell it it's 3 by 3, and it should run. Oh, there we go. And there's the inverse of A. And that'll be probably pretty accurate. I don't know if we can multiply the two together. So A inverse is the actual inverse, and A is the thing itself. So if I did find a matrix, I think I can just do it out of thin air. Let's define a matrix, say V equals, I'm going to multiply two matrices together, so it's going to be A, and then I'm going to use this at symbol, which I assume is the multiplication times A inverse. So that's print it the, do I need a semicolon? Not sure, can't remember now. Leave it for the moment. So, and then I'm going to print out V, which should be near the identity matrix. So I'm just going to use the same code here, but substitute V, A inverse for V, and that should tell me when I multiply the two. I mean, obviously it is, otherwise it wouldn't be giving me that, but I just want to check if that's the case. So now I've multiplied A times its inverse, and let's see if it's doing it here anyway. You can see A times there. Let's see what it does. Inverse of A. Oh, I shouldn't call it A. It should be, let's call it something like multiply out should be identity matrix. Let's run it again. So there's the inverse, and it says multiplied out should be the identity matrix. So that should be 1 0 0 0 1 0 0 0 1, and it's, well, that's 10 to the minus 17, so that's pretty close to 0, isn't it? It's never going to be exactly 0, and because our tolerance was 10 to the minus 10, it's quite interesting. But if that's on the norm, I think, yeah, which presumably is the Frobenius norm. Now let's see, when it picked the initial condition, where did it pick the, oh, it just picked the initial condition to be the identity matrix, which is not probably a good thing, because there are cases where that might actually diverge. I mean, for example, if I put that as 2, that probably won't converge. Let's see. Yeah, so it says matrix did not converge. That's because I've made the initial value too big, which is what happens with Newton methods. So there it is. That's how you, let's find the inverse of a matrix. So I've asked another question now. I've just said to do the same thing as before. In other words, to find the inverse of a matrix using Newton's method, but to plot all the elements, the convergence of all the elements on a graph so we can see them versus time, which is a sort of engineering thing to do. Let's use the Matplot library, which is similar to Matlab, and NumPy, of course, as before. And I think, again, it's got the convergence. It's got the initial value as the identity matrix, so I'm going to have to change that because that'll probably diverge. So here I pasted the code, the modified code in, and I put 0.1 times the identity matrix as the initial value. And let's run it. And there it is. So these are all 9 of the 3 by 3 matrix. These are the 9 elements versus time. Element 0, 0, of course, is 1, 1 in the matrix, the upper left. Then 1, 2, 1, 3 is 0, 0, 0, 1, 0, 2. And that would be 2, 1, 2, 2, and 2, 3. And so on, if you're interpreting it in mathematical terms. So that could be changed. I presume that's done in the, if that's done in the labeling, I think it is somewhere. But you see, it's good you don't need to know these things. You can go and alter them later. Then finally, what I did was I asked it to convert the above Python code to Matlab and just see what happens in Matlab. It was pretty quick and came out with this answer. It's just very similar, but of course it's in the Matlab code rather than doesn't need those extra libraries and things. So, yeah, it's using the same example. So here's the Matlab code, and if I run it, METN, there we have it there. So that's let's just put that over here instead, slightly different position. But other than that, it looks more or less identical to the Python version. So you can convert from one to the other very easily. And I guess you can go the other way from Matlab into Python. I think I've done that before. I think I did anyway, I can't remember. So there we go. So that's looking at this thing, which is not new really, but called Code Pilot, which I think is supposed to be improved coding. It is pretty good. I can't really fault it in the coding. In the mathematics, yes, but I wouldn't really expect it. What it should have done is it should have given a proper way of doing the initial conditions. I mean, I perhaps if I'd said that in the prompt, it would have given me the thing. If you didn't know otherwise, you might have problems there. You're thinking, why is it not working? But that's just down to it picked the initial conditions to be too big, which is a problem with Newton's method, but it gives very fast convergence. Okay, thank you very much.